Welcome to the Review and Preview Problems 991 to 998 in the CCG book. 991 says examine the map plan of a three-dimensional solid below. A. On your paper, draw the front, right, and top view of this solid. So the first view we want to draw is the front view. And we see that our highest stack on all three of our rows is 6. So when we're looking on from the front, we should have something that looks like this. When we draw our right view, I notice that I have 6 is my tallest, and then I have 3 in the middle. So my right view would be 6 on either end. And 3 in the middle. And then my top view, I have nothing here. So my top view will be 3, 1, and then 2. Find the volume of the solid. So for the volume, I can look at my map plan and add up how many cubes I have. And I get 24 cubic units. If the length of each edge of the solid is divided by 2, what will the new volume be? Show how you got your answer. So if we divide by 2, and we're talking volume, we want to cube that. So we have the volume of the new solid must be 1/8 the original. So the reduced volume must be 3 cubic units. 9-92, examine the diagram below. Given that triangle ABC is congruent to triangle EDF, prove that triangle DBG is isosceles. Use any format of proof that you prefer. So we know that I'm going to use a 2-column proof. And they told us the given, instead of given here, we need to write statements. The first statement that they gave us is that triangle ABC is congruent to triangle EDF. We know at the bottom we want to prove that triangle DBG is an isosceles triangle. So knowing that our triangle was given and our triangle is congruent, we know that triangle D, or angle B, is congruent to angle D. And we know that because if we have congruent triangles, that implies that we have congruent parts. So DG is congruent to BG. because if the base angles of a triangle are congruent, then the two sides opposite those are also congruent. So base angles are congruent. Sides opposite are also congruent, which then can tell us that DBG is an isosceles triangle because of the definition of isosceles, meaning the base angles and the sides are congruent. 9-93, the Portland Zoo is building a new children's petting zoo pen that will contain 6 goats. One of the designs being considered is shown below, the shaded portion. Assume the measurements are in meters. What is the area of the petting zoo? So the first thing that comes to mind is this side of our rectangle, if this is 4, has to be 8. 4 plus 6 would tell us that this side is 10. Which would mean this side is also 8. So to find this missing side, we could take the tangent of 78 degrees is equal to the side opposite over the adjacent. Use inverse functions. So x would be equal to 8 divided by the tangent of 78 degrees, which equals 1.7. So if we take the area of the triangle and do base times height divided by 2, we get 6.8 for this piece. We can take the area of the rectangle, which would be 80, 8 times 10, and subtract out 1/4 of this circle, which the area of the circle would be pi r squared. So pi times 4 squared is 16 pi. We only want 1/4 of that, so divide that by 4, and we get 4 pi. So we have 80 plus 6.8 minus 4 pi is approximately 74.2 meters squared. How many meters of fence are needed to enclose the petting zoo area? So the fence is going to be the perimeter. So we know here we have 4 plus 10 plus 1.7 plus 6. We need to find the hypotenuse of our triangle, which we can use the Pythagorean theorem, or we could use opposite over hypotenuse, which is sine. So the sine of 78 degrees is equal to the opposite, which is 8 over our hypotenuse. Inverse trig function, so x is equal to 8 divided by the sine of 78, which gives us approximately 8.18. In order to find this piece of our circle, circumference of a circle is 2 pi r, so 2 times 4 pi is 8 pi divided by 4. We only want 1/4 of it, is 2 pi. So when we add up all of those pieces, we get approximately 36.2 meters of fence to enclose the petting zoo. What will the density of goats in the pen be? Show how you got your answer. So if our area is 74.2 and we have 6 goats, we take our amount of goats and divide by the area of the pen, and we get approximately 0.1 goats per meter squared, which is the same as saying approximately 1/10 of a goat per meter squared. 9-94 says Sylvia has 14 coins, all nickels and quarters. If the value of the coins is $2.90, how many of each type of coin does she have? So the first thing we can do is we can set up an equation, and we know we're talking about nickels, so I'm going to use N for nickels and Q for quarters. So N plus Q is equal to 14 coins total. We know the value is $2.90. We know a nickel is 5 cents. A quarter is 25 cents. So we can set up a system of equations to solve this. I'm going to go ahead and use substitution. So I know what N equals. I'm going to substitute that into my problem. So 0.05 times 14 minus Q gives me a new equation with one variable, so I can solve for how many quarters we have. Use the distributive property, so distribute 0.05, so we get 0.7 minus 0.05Q plus 0.25Q equals 290. Combined our like terms, so 0.7 plus 0.2Q equals 290. The inverse of positive 70 cents is negative 70 cents. So we get $2.20 divided by 0.2 tells me Q equals 11. So if I have 11 quarters, I substitute that back in to my original. N plus 11 equals 14. Subtract my 11, and I know that I have 3 nickels. 9-95, West High School has a math building in the shape of a regular polygon. When Mrs. Woods measured an interior angle of the polygon, which was inside her classroom, she got 135 degrees. How many sides does the math building have? Show how you got your answer. Well, I know that the exterior angle connected to the interior angle has to equal 180 degrees. So if I subtract that, I can tell that my exterior angle is 45. I know all polygons' exterior angles equal 360 degrees, so I can take 360, divide that by 45, which tells me my polygon has 8 sides. If Mrs. Wood's ceiling is 10 feet high and the length of one of the sides of the building is 25 feet, find the volume. So if we are looking at an octagon, one of the sides is 25 feet. We know the interior angle is 135. So my central angle is 45. We can divide 45 by 2, which gives us, if we're looking at this smaller triangle, an angle of 22.5 degrees. Half of 25 is 12.5 for the base. To find the height of my triangle, I can use the tangent equals my opposite side over my adjacent side. So x is equal to 12.5 divided by the tangent of 22.5 gives me approximately 30.18. To find the area of my triangle, I do my base times my height divided by 2. I don't want to divide by 2 because I need 2 of them, so the base of my triangle, 12.5 times 30.18 gives me 377.25. I know I have 8 of these triangles because my figure has 8 sides. So when I multiply by 8, the area of my base is 3,018. I then need to multiply that by my height of my building, which was 10 feet. So I get a volume of 30,180 feet cubed. 9-96. Given the information in the diagram below, prove that angle C is congruent to angle D. Write your proof using any format. So we know that line segment DA is congruent to line segment CB because that's given. We know that angle DAB is congruent to angle CBA because they are both right angles. And that is given. We know that AB is congruent to AB because it's a shared side, which is the reflexive property. So we can tell that triangle DAB is congruent to triangle CBA by side angle side congruency. We then can say that angle D is congruent to angle C because if we have congruent triangles, it implies that we have congruent parts. Write the equation of the exponential function that passes through the points 248 and 5750. So an exponential function is in the form y equals ab to the x power. So if we know our y value is 48, we can set up two equations. We can then get a by itself. We then know what a is, so we can substitute that in to our other problem. We can simplify using laws of exponents. So we get 48 equals 750 over b cubed. Use inverse operations. 48b cubed equals 750. Divide by 48. And b cubed equals 15.625. Cubed root is the inverse of cubing something. Gives us b is 2.5. We then can use either of our points. I'm going to choose the smaller one. 48 is equal to a times 2.5 to the second power. Divide by 2.5 squared. Gives me 7.68. I then can write my equation as y equals, my initial value is 7.68, my multiplier is 2.5 to the x power, and I know that this equation goes through the 2 points above. 998, multiple choice. Jamelia has started to construct a line parallel to line M through point Q below. Which of the possible strategies below make the most sense to help her find the line parallel to M through point Q? Measure angle QPR with a protractor. Use the compass to measure the arc centered at P. Then place the point of the compass where the arc centered at Q meets QP and then mark off on the arc. Construct line QP or measure PR with a ruler. So in order to get a line parallel, B makes the most sense.